Hello my future engineers, how are you all? Welcome to our channel Diksha Karnataka, where learning is fun, where formula meets tricks, and where your stress during studies, your portions meets a proper strategy. Okay, so today's topic of discussion will be the session number 3 in the chapter relation and function. What we're going to do today in this session? So in this session today we'll do the KCET PYQs. Okay, I hope this is very clear. KCET PYQs. Alright, so let's see this the session planner, the chapter planner, how we have done the chapter. So what we have over here, you can see, so we have covered the entire chapter relation and functions from PU2 in 4 parts. Okay, of course the part 4 is yet to come, but part 1 is types of relations, part 2 was types of functions, part 3 we are doing today, which is the KCET PYQs, and part 4 is going to be your JE PYQs, JE mains PYQs. Okay, again, as you see in the Sankalp segregation also, the two sections are concept sessions. Second one is KCET PYQs and JE mains PYQs. I hope this is clear. Okay, this is how we're going to plan our sessions in all the chapters as well. Some chapters might require more concept sessions, so in this particular case you can see there was only 2 concept sessions, but there can be a chapter, for example, there can be a chapter like in calculus part, we are dealing with integration, then I might need more than 2 sessions to complete your portions over there. Okay, there might be more than 2 parts involved. Let's have a look what is next. So next is why we are doing all of that. Why are you here? Why are you studying from me at this platform? Reason is very simple, because we are somebody, our platform is is the best platform known for CET, and what we're doing over here is producing rankers. Okay, these are the results from 2025 KCET batch. If you see over here from the YouTube itself, we had Prajwal at 171, we had Kiran at 443, we had Diksha at 693, and Samiksha at 752 rank, and Sachin at 934 rank. There were many more. Okay, you can see 11972043 all the way to 5534 for Gagan, and as I can see, Harshit is there, Chinmaya, Tanmay, Mohammed Sahil, Kirtana, Atharva, Anshuman, Akash, all these and many more. Okay, we can't show all the names over here. So this is why you're here. And what is your goal? I'm going to assign a task to you. Your task is very simple. You are supposed to be one of the rankers in the KCET 2026 batch. Okay, your photo, your name should be displayed over here. That's your goal. Works that much. Okay, be completely assigned and structured in the preparation journey. Okay, ask for any help that you need to make sure that you are among the toppers, the rankers of the next year's results in CET, of course. Okay, so this is the goal that we have set for ourselves. Now if you look at quickly in the chapter inside what we have, okay, so this chapter sets foundations for topics like calculus. We know that very well. Okay, for example, the chapters like continuity and differentiability of the calculus, we deal with different type of function, right? There we deal with different type of functions. For example, we have modulus function, we try to redefine it. So where we learn the modulus function, we learn it over here in the function section. Okay, next we have questions in the exams are usually very direct. Okay, the question that you see in the examinations from the chapters are very much direct questions. So if you know your concepts well, if you're familiar with all the concepts, then it'll be very easy and fast to solve questions from this particular chapter in your CET examination. Okay, now we will deal with types of relations like reflexive or symmetric. Okay, and there's one more, which is a transitive relation. We'll deal with all of that, of course, and different types of functions helping us to think logically. That's very important, right, for any examination point of view. If you're not logical about the question, then if the problem statement is a little bit changed, what will happen? You'll be stuck. You'll take more time to do that, and we don't have that liberty, do we? Of course not. So means we have to be very logical in our approach. What does the problem is saying to us? We have to learn it quickly by reading the problem in one shot. Okay, so again, we will use what we're going to do in this chapter. So use graphs, arrow diagrams, and sets to learn the various concepts involved in this particular chapter. Okay, now what is the goal of today? What is the session's outline? So session outline is very simple. We're going to solve 20 plus PYQs from CET last 10 years paper, and we'll solve in very detailed fashion. Okay, we'll not give you just answers, option is this, like that. No, I'll solve in very detailed answers so that you have all the understanding that you require to solve that particular problem. Okay, so yes, you can use the shortcut tricks, that's not a problem, but you should know the concept behind it as well. So I'm going to solve it in detailed fashion with the analysis of the every single question that I've taken over here. I hope that works. Let's move on to a session now. Okay, question number 1 for you. So let's begin now with the question number 1. The question number 1 is the set X contains 7 elements. Okay, so the cardinal number of the set X is actually 7. What is that saying? Set Y contains 8 elements. All right, so they're saying N Y is 8. They're asking us number of bijections. It means number of 1-1 onto mapping from X to Y. From X to Y. Okay, we are looking for bijections. So okay, we'll have the answer as 0. We'll have the answer as number of bijections will be 0. Reason is very simple, because we are getting n of x is less than n of y. The cardinal number of the set x is less than the cardinal number of the set y, which can't be the case. For the bijections to be true, it's a concept part over here. For bijections, okay, for bijections to be true, you should have the case as n of x should be more than or equal to y. This is the result, okay. In this case only we can say the bijection exists, means one on two cases exist. Otherwise we can't say that. In this particular case we have n of x, the cardinal number, to be less than the cardinal number of y. Hence answer is 0. Option A is correct. I hope this is all clear, right? Very clear. Moving on to the next question. Okay, question number 2. What is that? If A is equals to, okay, so basically x is the element of the set A. It's a natural number, great, means all the elements are natural number, and they're less than 5, okay. So I can write the set A, all natural number less than 5 means starting from 1, 2, 3, 4 and 5. So I can say simply over here the cardinal number of the set A is also 5, not a problem, right? Okay, there are total of 5 elements, right? 1, 2, 3, 4, 5, so the cardinal number will become 5, alright. And for the set B we have, it's a quadratic, okay. Factors we can find directly, no? Very simple. Factors are 2 and 3. If you can see that, minus 2x minus 3x will make minus 5x. When you multiply it will give you 6x square, okay, positive sign. So answers are 2 and 3 is your actually the elements of the set B, okay, works. So from here we can say directly is NB is 2. Now what are they asking? The number of onto functions. Number of onto functions. Number of onto functions is given by n power m minus n. Okay. So n is what represents the number of elements in the set B, which is going to be 2. M represents the number of elements in the set A. So 5, 2 power 5 minus 2. 2 power 5 minus 2. Okay. So I get here 32 minus 2 equals to 30. Equals to 30. Answer should be option B. Okay. So I'll try to give you the formulas if wherever it is possible. So for example, in this case, this is the formula. In previous case, I already given you. This was the concept over here. So I'll give you the concepts whenever it is required. Let's move on to the next question. Okay. This is all clear, right? No problem over here. Let's move on to the next question. Okay. So we have, if a relation R on the set, okay, 1, 2, 3 be defined by, okay, the relation has only one element in it, only not element, only one ordered pair in it. It means it cannot be reflexive first of all, because if it is defined on this given set which has the element 1, 2, 3, for the relation to be reflexive, I must have 1, 1, I should have 2, 2 and 3, 3 as well. But in this case, I don't have that. It means reflexive not possible, okay? Reflexive not possible. Let's look for other two, which is transitive and symmetric. Symmetric, yes, 1, 1 is symmetric only, right? We can say symmetric possible. Symmetric possible. Let's look for transitive now. For the transitive, I've taught you this. Remember, if you can't check, basically if you can't object on the transitivity of the relation, I'll repeat myself, if you can't object on the or create objections on the transitivity of the relation, it means it will be always transitive. For example, check here, we have 1, 1. Can you check this in any way? There's no ordered pair to check the transitivity. Simply you'll say this to be always transitive. I hope I told you this in the session as well, in the lecture session, that whenever I'm teaching you this concept or this questions on this, I explain this with the help of a question. What's the concept? I'll repeat myself. The concept is, if there is no way to create or check for the transitivity, always consider the given relation to be transitive. Works? Alright. So this is a relation, symmetric transitive but not reflexive. Okay, so answer will be option B, right? Symmetric and transitive but not reflexive. Okay, option B is correct. This is given, yeah. Okay, so A, B, B so far. Next question now, fourth one. We have a set A such that x is not a positive integer. So if you try write this list in a weird way, not the standard notation, not a positive integer, not a positive integer. Right here A, not a positive means, so let's write Z positive integer, and not means transpose of that. Well, yes or no? Please check. The set A is not a positive integer, means from the all real number set. All integer, all real number set, right? All real number set, remove all the positive integers. So I've taken here positive integer Z plus and remove the, by taking complement or by taking your transpose. This is okay, right? Alright, so we have x is not a positive integer. Done. Define A to R for the element 2x upon x minus 1. Then f is what? Okay. So let's check for the 1 1 onto function. 2x1 upon x1 minus 1 equals to 2x2 upon x2 minus 1. What I'm doing actually here is, I'm writing here f of x1 equals to f of x2. That's how we solve these questions. F of x1 equals to f of x2. Alright. So 2 and 2 is cancelled, cross multiply, end up with x1 x2 minus x1 equals to x2 x1 minus x2. Cancel. Right now x2 into x1 is x2 x1. x1 into minus 1 is minus x1. Same way I'm doing the cross multiplication on the other side as well. Okay. This is cancelled. I'm having here. I hope this is okay. This is okay. From here I get. This is true. No problem over here. Please check. Starting from the f of x1 equals to f of x2, reaching x1 equals to x2. That works. So we can say function f is 1 1. F is 1 1. Okay. Now for onto part, what do we have? Okay, we'll take the function like this. Y equal to 2x, x minus 1. Right now the subject is the variable y. For now, the subject is a variable y. We'll do what? We'll give the subject to be, or we'll make the subject by making some modifications as x. So I'll make the subject to be x. From there I can find the limitations, the restrictions on the variable y. Okay, let's do that. So that will give me simply the range of the function. Okay. So multiply, I get here, 2x equals to xy minus y. Move on this side, I can move this on. Okay, so I get here y. Okay, no, not required. All right, 1 second. So 2x minus xy, okay, equals to minus y. All right, take here x common. Okay. I'm getting the x value now. Have a look. So I'm getting this x as basically, if I remove the minus sign in the both numerator and denominator, I'll end up with y upon y minus 2. I'll end up with y upon y minus 2. So if you have to write the restriction on this given function right now for the variable y, what are you going to do? Y belongs to all real numbers except for 2. You can't take 2. If you take 2, what will happen? It will become 2 upon 0. It will become 2 upon 0, which is undefined. Okay. I'm getting here y equals to all real minus 2. It means, now check, this is my range. Now is this equal to codomain? What is codomain, sir? Codomain here is all real. So I can say not equal to codomain. So what I get here range is not equal to codomain. It means not onto. The function f is not onto. Okay. So I get the answer directly over here as injective but not surjective. Option A is correct. Injective but not surjective. Option A is correct. Injective because it is 1 1. 1 1 is also called as injective. Onto because it is not coming as onto, so not surjective. Okay. So this is clear. This is clear. I hope this is clear. Let's move on. So look, I have taken a little bit extra time to solve this question because I wanted to explain you every single part of it. But if you are doing it for the exam purpose, you can also skip some points. What are the things that can you skip? You can see directly from here, no, that this will be, after looking at the statement, if you write it like this, you can directly, by practicing a lot of sums, you'll feel that it will come directly as 1 1. So just writing this statement is good enough to find the 1 1 function. What about onto function, sir? Yeah, for onto you have to do this relation. You have to do this, but you don't have to do all the steps the way I have done. You can do it quickly in one step. Okay, that can happen in the practice sub. Moving on. Next, if A is a set having 6 distinct elements, okay, the number of distinct functions from A to A which is not bijection. So we're looking for those functions which is not bijections. So we can do what? We'll find the total number of functions, total number of bijections, and subtract it. Don't you think? I'm looking for, my result is all functions which is not bijections. So I'm going to find total functions, total number of functions, okay, minus number of bijective function. Works. For this we have the formula as 6 power 6. 6 power 6 n power m. In this case the elements, the set is defined, the function is defined for the same set, no, A to A, right? So we have to write 6 to 6. Bijections is written like this, 6 factorial. This is my answer. Option C is correct. Option C is correct. This is the result for all those functions which is not bijection. This is for the bijection part, all the function. So all those functions which is not bijection will be given by the result 6 power 6 minus 6 factorial. F is defined from all real number to all real number. Fx is given as x power 4. If I find here f of minus 1, I get minus 1 power 4. It'll give me 1, right? Let's find now this time f of 1. What I'm going to get? Same thing, 1 power 4, 1. So I'm getting here simply f of minus 1 is equal to f of 1, whereas actually minus 1 is not equal to 1. F of minus 1 is equal to f of 1, but minus 1 is not equal to 1. It means the function here given fx not injective. Not injective. I hope this works for you. It's not an injective function. Alright. Now for onto function. For onto function, have a look. Okay, for onto functions, okay, it's not onto as well because your, please check, your codomain is actually all real numbers. All real numbers is your codomain, whereas your range is only positive. Anything you put in this function fx, it comes out as positive only, no? Because power is 4, okay? So your range is coming out as, what dear? Only positive real numbers or 0. Or 0, okay. Even 0 can be there. So only positive number or 0. Both is possible. So I can say directly here is codomain is not equal to range. Hence it is the function fx is not onto or surjective. Okay, so answer is not injective, not surjective. So neither one nor onto. Option B is correct. Neither one nor onto. Option B is correct. Okay, let's move on. I hope this is clear. Very simple question. Okay. The set A has 4 elements and the set B has 5 elements. Then the number of injective mapping that can be defined from A to B. Okay, so number of injections. We have formula for this. Remember, we have 5 P not 3, 4 is there, right? Yeah, this one 5P4. That's the formula that we have. Number of injections, number of one function is defined as NPM. Okay, in this case 5P4. I get here Answer is 120 then. That's simple, sir. That's simple. Yes. Okay, let's move on. They're saying that if function is defined from all real number to all real number, basically your domain is all real and codomain is also all real. Okay, and your fx is like 1 by x. Fx is given as 1 by x, is it? Not possible, sir, because for all real we'll also have x equals to 0, right? And for this kind will become 1 by 0, which is undefined, right? Undefined. It will be undefined. Answer is B. Whenever I say domain, what is the meaning of domain? Domain means at all the points inside the domain, the function should be defined. That's the definition of domain, right? At every point in that interval, the function should be always defined. Okay. Whereas if I write belongs to a real number R, 0 is a real number. Yes, it is. At that point, what happens is 1 by 0 is not defined. So basically what it means is either this domain is wrong, or in this case they are not saying that, they're saying this is all real only, then it means function is not defined. Okay. So either change the function or you write this as not defined. Okay. When I say change the function, basically I mean change the domain. Okay, next question. Let S be the set of all real numbers. A relation R has been defined on S by A or B, A minus B mod is less than 1. Okay, then R is what? Okay, reflexive, if I am checking, it means A minus A, which is going to be what, dear? 0, which is of course less than 1, so reflexive is true. Correct? Let's check for symmetric. For symmetric, what we have? For the symmetric relation, we have the saying that ARB is true. ARB is true. It means what? It means mod of A minus B is less than 1. Then case is PRA should be true. BRA should be true. Should be true. Let's cross check. PRA means B minus A. Please check. Works only, no? Yes or no? Yes. If you write A minus B or B minus A in the modulus, doesn't mean anything. It means difference. Doesn't matter what is the magnitude, because whether it is plus or minus doesn't matter. Okay, because we are talking about modulus function. It means whether it is minus 2 or plus 2. If I take the example of minus 2 plus 2, it will come out as positive only, right? If let's say A minus B, excuse me, if I have A minus B is, let's say, 2, then of course B minus A will become minus 2. Apply mod on this, answer will always be 2 itself. So whether you take A minus B or B minus A, both will be less than 1 in this particular case, not 2. 2 I just taken as example to explain you the modulus part. Okay. Now last part is check for transitivity. So the symmetric also is true. Check for transitive relation. Transitive relation. And for this case, for the transitive relation, what can we take example? Okay, I'll take 3 elements, 1, 2 and 3. 1, 2 and 3. Let's write 1 R2. It implies that 1 minus 2, which is how much in the modulus, is 1, which is of course less than or equal to 1. In this case we are getting equal to case. Alright, let's write here 2R3. Okay, so 2 minus 3, which is nothing but again 1 only, right? Because it's going to be minus 1, so I'll get here result to be 1, which is again less than or equal to 1. So works. Both are true. Both has to be true. That's the condition of transitive relation. The combination of these two, I get here 1R3. Please check. I'm getting here 1 minus 3, which is nothing but 2, which is actually not less than equal to 1, because the 2 is more than 1, right? So what I get over here, this is not true. These two are, if you remember, I taught you this if statement, and this is your then statement. If these two are true, then this has to be true. Whereas not, this in this particular question, not the case. It means we can say simply transitive relation is not going to be true for this case. Okay, this is not possible. Answer will be option C, reflexive, symmetric but not transitive. option C. Let's check. This works? This works for all of you? Okay, I hope this works. Let's move on. Next question. It says now, if f is defined on natural number to natural number, it means that domain is natural number and codomain is also natural number. Okay. Then the function is defined as f of n when n is odd is given as n plus 1 by 2, and when n is even, simply n by 2. Okay, something like this comes for, remember, the median function. Yes. Alright, so how do we solve it? We're looking for 1 on 2. Let's check. I'll take a number f of 1. F of 1 will become what, dear? Odd case. So 1 plus 1 by 2, how much is this? 2 by 2, how much is this? 1. This is f of 1. Let's find now f of 2. 2 is even. I'm going to use this function now. 2 by 2, which is 1. So I'm getting here f of 1 equals to f of 2. Okay, but 1 is not equal to 2. It means from this 2 you can say that not 1 1. Not 1 1 function. Remember, if f1 and f2 is equal, it means that 1 and 2 should be equal. Not the case in this particular given question. So we have checked for 1 1 on 2. Okay, 1 1 function. Let's check for on 2 now. Let's check for on 2 now. For on 2, what you're gonna do? I will take both the cases individually. Case 1, let's take for the odd function. I'll write here y equals to n plus 1 by 2, which gives me 2y minus 1 equals to n. Think about it. If I take this y to be any natural number, if I take this y to be any natural number, I get this n also as natural number. Yes or no? If I simplify this, 2 into y and this 1 comes over here, right? 2 into y and 1 comes over here, I get 2y minus 1. So if I take this y to be any natural number, which is the case, y is the codomain. So for every value in the codomain, you have a simply element in the domain set. N is the domain set. This is your domain set, right? And this is your codomain set, right? So for every element y from the codomain set, there exists a natural number or there exists an element in the domain set. Okay, please check. 2 into natural number, any number you can take. 17, 34 minus 1, how much is that going to be? 33, which is a natural number. So for every value of y from natural number set, I'll have n as a natural number. Okay, so this is okay. This part means on 2. This part means on 2 is yes. Now for the case 2, when we talk about even function, again we'll take the same condition. Y belongs to codomain natural number. Codomain natural number. Okay, so I get here y equals to n by 2, cross multiply, I get 2y equals to n. You take any natural number n, multiply that with 2, the result is also going to be a natural number. Think about it. Any number, 105 times 2, 210. Any number you take for natural number as y, n will also come out as natural number only. It means even this is a onto function. Think about it. Okay, for y equal to natural number, this is coming from the codomain. I have n as natural number, which is the domain part. So for every element in the codomain, there exists what? An element in domain. It means what? None of the element in the codomain is left out. It means what? Simply onto function, right? That's the definition we learnt. Okay, so yes, there's other thing that we check for the range and codomain, but definition for the onto was what? None of the element in the codomain should be left out. Y from the codomain, there is a value respect to this y that exists in the domain. It means every value of y which from the codomain has some element in the domain set. Okay, it means onto function. So basically both the cases are coming as onto functions. So not 1 1 but onto. Not 1 1 but onto. Option A is true. Next. Fun question. Next one. The number of bijective functions from a set to itself. Okay, same way the number will be n, let's say, then the answer will become n factorial. In this case n is given as 97. Answer will become bijections, right? So 97 factorials. Option is C. Option is C. This works. Moving on. Let A be the set of all animals. A or B, if A and B are in different zoological park actually, then R is what? It can't be reflexive, sir. It can't be reflexive. How come, sir? Because if I write here A R A, it means what? It means it implies that A and A are in different zoo. Can the same thing or same animal be present in the two different zoos? I'm not saying the same species of the animal. I'm saying same animal. Okay. Let's say I'm talking about an elephant. The elephant has a name. Okay, Zumbo. Can the Zumbo be present in both zoos at the same time? Not possible. It means reflexive, so gone. Not possible. Okay. Okay. Let's move on to what I'm talking about next is symmetric. Okay. So we can't have the same thing present in two different zoos. Second is symmetric. For symmetric, possible, right? A and B. If I have two different animals, A, B, if this, let's say this animal A belongs to zoo number 1, animal B belongs to zoo number 2, then again, opposite also is going to be true only, no? So if A and B are in different zoos, it means B and A will be also in different zoos. Correct, na? If A and B are in different zoological parks, then B and A will also be in different zoological park. Works or not? Yes. It means symmetric is yes. Let's check for transitive now. Third case, transitive relation. Now, for this actually transitive relation, we can have the cases. We can have the cases where you'll find that transitive will be true. But I'm going to look for one such case where it is not true. Okay, because we know that all the relations has to be true everywhere. Okay, condition is now, check this out. Let's say I have a zoo 1 and zoo 2. I have, let's say, animal A here, animal B here. I can say A or B is valid. It means that both of them has to be in different zoos. So A or B is valid. Okay. Now if I write here, let's say B is here and C is here. Again for this case, I can write here BRC is also valid. BRC is also valid because different zoos. But if I write ARC over here, what are you gonna get? For ARC, please check. For ARC, you'll have in the same zoo. So AB when I write, I mean the same thing, right? It means A and B are different zoos. PC I write here, B and C are different zoos. Okay, but AC, their intersections. Okay, AB, BRC means AC, ARC. Not possible because they're talking about different zoos. Different zoo. In that case, what is going to be the condition over here? Not true. Okay, answer is going to be only symmetric. Let A be a set of compartments in a train. Okay, then the relation R defined on A as A or B if A and B have the link between them. Okay, so train compartments. Okay, so they're saying that this consists of the set of the train. Okay, set of compartments. Let's write the compartment to be A, B, C. Compartment to be compartment A, compartment A, compartment A, B, C. Sorry. Okay, so I can say A and, if I'm talking about what relation is defined as, A and B have the link between them. So A and B has link between them, and B and A has link between them. It means symmetric is true. What about reflexive, sir? Not possible. How can the compartment A has link with itself? Can you write A over here? Can you write A with A? Not possible. Means reflexive. Not possible. What about transitive now? Please check transitive relation. A with B, B with C. You have A with B, B with C. A is linked to B, B is linked to C. But can you say A is linked to C directly? No, you can't say that. A linked to C is not there. It means this is not transitive, sir. Answer is only symmetric. B is correct. Have a look. Okay, simple question. Moving on. if a set A that has 13 elements and R is a reflexive relation on A with the elements, okay, set A has the 13 elements, R is a reflexive relation on A, it means that I can go minimum of what, dear? Minimum will be n only, no? And it goes all the way till, okay, it goes all the way till n cross n, correct? This is the formula. Minimum of 13, okay, and goes all the way till 13 into 13, okay. This n will vary from, like this, please check, 13 to 169, 13 square, right? So 169, reflexive relation, okay. So 169, answer will become C. Have a look, okay. Any concerns you have, any doubts you have, leave me with your concerns in the comment section. Alright, let's move on now to the next question. Again, these are CT level questions, so they are not that challenging. So let X be the set of all engineering colleges in a state of Indian Republic and R be a relation on X defined as two colleges are related if they are affiliated to the same university. Okay. So if I talk about the first one, reflexive, correct, no? A given university which is, given college which is from the same university will be affiliated to the same university, right? If I talk about ARA, a given college which belongs to the same university will be affiliated to the same university. It means it's true. ARA is true. Okay. Second one will be what, dear? Symmetric. So in this case we talk about ARB. ARB means A and B from the same university, correct? It's given like this. Then BRA also same thing. If I have two colleges which are affiliated to the same university, then you take AB or BA. Means the same thing, right? College 1 you take first or B you take first. Doesn't matter. So even ARB or BRA will be both what, dear? Possible, okay? They belong to the same university. Okay, great. So this is also true. Check for transitive now. Check for transitive now. So in this case we have, if I write here ARB, it implies A and B belongs and affiliated to the same university, okay? Belongs to same university, okay? And BRC means B and C belongs to same university, right? Then if I write here A and B belongs to same university, A and B belongs to same university, and B and C belongs to the same university, it means A and C also same university. AB and BC are from the same university, it means AC will also be the same university having the affiliation with. A and C will also have same university affiliation, okay? It means also true. So a relation which is reflexive, symmetric and transitive at the same time is called as equivalence relation. Option D is correct. Option D is correct. Let's move on. Alright. A signum function from R to R defined by fx 1, 0, minus 1 if x is more than 0, x is equal to 0, x is less than 0. Okay. So it cannot be, please check here. This is your codomain, right? What's the range, dear? Range is how much? Range is simply 1, 0, minus 1. So minus 1, 0 and 1. Are they equal? They are not equal. It means not 1, 1. Sorry, not on 2. Excuse me. Not on 2. What about on function, sir? Draw the graph. You will have at 0 it is 0. Okay. At more than 0 will be open here, always 1. And this is minus 1. Okay. For this you will have again, sorry, please check, open here, this side. So if you check here, for all these values of x, you have only one value of y. Same way, for all these values of x, the negative value of x, you have same y as minus 1. Simply it means what? It means not 1 1, not 1 1. Okay, so simply we can say that many 1. This means that many 1 is true. Option C is correct. Not 1 means many 1, means for the same value in x, for the different value in x, you have same value in y. So many 1. Moving on. We have function defined from natural number to natural number. The domain is natural number and codomain is also natural number. Okay. The saying function is x square plus x plus 1. Alright. Then f is what? It's a quadratic function. Okay, it's a quadratic function. Have a look. When x is 0, y is 1. Okay. That's the function actually. That's true. Because you don't have any negative value. Because your domain is natural number. Domain is natural number. It means you'll have a open over here actually. You'll have a open over here. Because at there is no 0. Domain is not there actually. This part is not there. There is no 0. Natural number means 1 to, move on from there. Okay. 1 to infinity. Alright. This is your domain. What about range, sir? Your range is, they have given the codomain. So I write the codomain first. So your codomain will be again given as natural number. What about the range? Range is from, this is going to be 1, 1. Okay, I can't take 1 to infinity. Now it might feel that it's actually going to be what, sir? It might feel that it is going to be a value. 1 to infinity means natural number. Okay, you might feel that way, but it's not natural. Actually, you'll have all these points, no? You'll have all these points, and all these points will not be natural number. It'll be simply real numbers. So you'll have all real numbers between this and this. You'll have all real numbers between 1 to infinity. Between 1 and infinity. Okay. You get all real numbers. So can this and this be equal? Can range and domain be equal? Codomain, sorry. You can see here, range is clearly not equal to codomain. It might confuse you, thinking that's at 1 to infinity. That's how you define that. That's how you define natural numbers. 1, 2, 3, 4 like that. But it's not the case. 1 to infinity means 1, 1.11111, 1.00001. That all will come. Okay, it's an interval. It means real interval. Got it? Hence we'll have range and codomain not equal to each other. Got it? Resulting in not onto function. Now check for on function. If you draw the graph one more time, have a look. Any point you take, you'll have only one intersection because it is defined only for natural number. If it was defined for real number, you'll have this side also. It's a parabola, right? You'll have this side as well. But it is not defined for real numbers, only for natural number. So your function will become 1 1. Function will become 1 1. Function will be 1 1 because there is only one intersection every time you take the line parallel to x-axis. Okay. So 1 1 on 2. 1 1 on 2. Sorry, 1 1 not on 2. Sorry. Option C. 1 1 but not on 2. Okay, works. Moving on. Now, which of the following is the bijective function on the set of real numbers? Option A is correct. It's a straight line, right? X is 0, y is minus 5. So, y is 0, x is 5 by 2. 2x minus 5. Any place you take, you'll get 1 1 function. Okay, you'll get only one intersection, and depends upon what's the domain over here. Sorry, what is the range over here? All real. And what is the codomain? Again all real. Okay, saying that defined on real numbers. Defined on real numbers. Answer will be option A. This is not true because mod of x will be quadratic, will have both sides. So we get two intersections here as well and here as well. 2 means these two will be the case of not 1 1 or many 1. Okay, so ignore the B, C, D, only A is the right answer. Option A is correct. What is the next question? Which of the following is not 1 1? Not 1 1. This is 1 1 or not? Yes. It's a straight line or is 1 1 function. Quadratic. Quadratic means it has two parts. This is a graph. This is the graph, okay? You'll have this has two intersections defined on, okay, anywhere you define, okay, defined on real numbers. Defined on real numbers, please check. So for x belongs to all real, you'll have, please check, this and this has two intersections, means not 1 1 actually. This function is given as many 1. X cube, you remember? That's your function. So it will be coming as always 1 1 only. Same goes with the rational function 2x plus 1 upon x minus 7. Okay. So answer will be actually your quadratic x square plus 7. That's your answer. Next is, sir, for the function given like this, your domain is all real for minus 1 and 1. So your domain is all real except for minus 1 and 1, because very simple. Putting it over here will give me the function to be undefined, 0 and 0, right? So you get here 1 minus 1 becomes 0, whether you take minus 1 or plus 1. Square will make it positive, answer will be 0. Okay. And your codomain is all real. Let's find it out. So first we'll do, okay, we'll do this. 1 upon x1 square minus 1, 1 upon x2 square minus 1. Cross multiply now. Okay. I'm taking this as f of x1 equals to f of x2. Cross multiply. So I get here x2 square minus 1 equals to x1 square minus 1. This and this is cancelled. I am getting here x2 square and x1 square. So I get x2 as plus minus x1. If you take the root on both sides, we will have both plus minus x1, which means what? This function is actually many 1 or not 1 1. Many 1 or not 1 1. Okay. Checking for the range part now. So I'll write this as y equals to 1 upon x square minus 1. So we're going to make what? We're going to make x the subject as x. Usually what we do, we write the function in terms of y and x and make subject x this time to get the restriction or the limitation on the variable y. 1 second. X minus 1 equals to 1 by y. Move 1 on this side, I get x square equals to 1 by y plus 1. So I get 1 plus y upon y is x square, giving me the value of x as root of 1 plus y upon y. What I have the case from here? Please check. So I should have 1 plus y to be more than equal to 0. Okay, moving the 1 on this side. And the other one, denominator, y can never be equal to 0. Okay. Y can never be 0 and it should be always positive. So 1 plus y is always positive. So look at here. We get here minus 1 closed to 0 open, because 0 is not possible. Union 0 to infinity. This is your y value. This is nothing but your range, sir. And what's your codomain? Your codomain is what? Is all real. You can say this directly from here, these two are not equal. So your codomain is not equal to your range. It means what? Not onto function. Not onto function. Not onto. The given function to you is neither 1 1 nor onto. This is many 1, right? So not 1 1 and not onto. So neither 1 1 nor onto. Option D is correct. Have a look. Very good question. Done. Next is domain of sine inverse of GIF of x. What is this? GIF means greatest integer function of x. Okay. So we know that sine inverse of x, if it was like this, y, we know y belongs to where to where? Minus 1 to 1. It means simply this belongs to where to where? Minus 1 to 1. Minus 1 to 1. Correct, na? If I'm replacing this GIF of x by y, it means what? This y belongs to minus 1 to 1. Simply this GIF of x belongs to minus 1 to 1. Okay. So for what value? Draw on the number line. For what value of x this GIF will give me minus 1 to 1. So if you take anything less than minus 1, basically minus 1.5, answer will become dear minus 2, means not possible. Means the minimum value of x, if you take from here, the minimum value of x has to be what, dear? Minus 1. This is clear. If you go minus 1.001, if you go here, minus 1.001, answer will become what, dear? Minus 2. So I can't go below or behind of minus 1 on the number line. That's a clarity. Means I have to start, I have to include this solid line and move like this. Okay, I can't go behind minus 1 because there is a constraint over here, minus 1 to 1. What about on the side? Can I take 1? Yes, sir. If I take GIF as 1, no? If I take GIF as 1, answer will be 1. I take GIF as 1.1, answer is again 1. 1.9, answer is again 1 only. If I take 2, answer will become 2. So anything but 2, less than 2 we can take. 1.9999, do it. 1.999, answer is 1. So all the time when you are below the number 2 or less than the number 2, you are okay. It means simply right here 2 but with the open sign. Okay, less than, not equal to, only less than 2. So this is your answer. Please check. These are just examples that I have taken over here for different numbers. Option B is correct. Minus 1 is closed and 2 is open. Minus 1 is closed and 2 is open, not closed, not closed, and minus 1 has to be closed. Okay, so minus 1 is closed and 2 is open. Option B is correct. Works. Okay, let's move on. And that's it for the session today. If you're new to the channel, make sure that you are subscribed to the channel. Okay, and if you want something else to be done in the session, let's say you want more questions, if you want different type of questions, let me know in the comment section of this video. I'll get back to you with a improved and session based on your requirements. That is a promise. Okay, we are here to help you out in all the possible way we can do academically. Okay, so make sure that you have a concern, you have a requirement, you want to leave it, and we'll take it into our consideration making the next or upcoming sessions for your practice or a theory session. Okay, now if you're new, please subscribe to the channel. If you like our content, like our videos, like our sessions, and it gives us big confidence going in and producing and working on more content, producing more contents to deliver for all of you. Okay, I'll see you again very soon. Till then, take care. Bye bye.